Welcome to Algebra 2. This is our chapter on graphing functions, and we are going to be talking about Section 4, writing linear equations today. So first off, to write a linear equation, we have three formulas that we can use. The first one is standard form. Standard form is always in a linear equation, and it's ax plus by equals c. That one is not too practical for us to write in if we're just giving bits and pieces of a line. So we're going to be using the point-slope form a lot. The point-slope form is useful when we know a point on the line, x1, y1, and we know the slope m. If we know one point and one slope, we can put the formula into point-slope form, which is y minus y1 equals m times the quantity x minus x1. Okay? Slope-intercept form. This form is the form that is most commonly used as the final answer for a linear function is in slope-intercept form. You can put something directly in slope-intercept form if you know the slope and you know the y-intercept. The y-intercept in this equation is denoted by a b. Slope-intercept form is y equals mx plus b. Okay? Now, we also need to know the difference between parallel lines and perpendicular lines. Parallel lines are never going to cross and they have the same slope. So their slopes are equal. So if we know one slope is of 3/4 and we want to find the parallel slope to it, that also would be 3/4. Perpendicular lines, we have one line, the other line intersects it, forming a 90-degree angle. We know that perpendicular lines, their slopes are negative reciprocals. A lot of people also call this opposite reciprocals. For example, if we know one slope is 2/3, the perpendicular slope would be negative 3/2. Okay, they started off positive, so it would be negative to make it a negative, 2/3 slope to get 3/2. Similarly, if we started off with a negative slope, say negative 4/5, the perpendicular slope then would have to be a positive 5/4. Okay? So now we're going to put this into action. So we're going to start off by writing an equation in slope-intercept form for the line described. So here, m equals 2, and we pass through the point negative 3, 2. Our ultimate goal is slope-intercept form. So our ultimate goal is y equals mx plus b. However, in this equation, we are not given the y-intercept, we are given a point. So since we are given a point and a slope, we are actually going to start off with point-slope form first, which is y minus y1 equals m times x minus x1. Well, now we fill in our point, x1, y1, and we fill in our slope of 2. So y minus y1 is 2 equals m is 2. In parentheses, x minus a negative 3. Now we simplify this. In order to get this in slope-intercept form, notice here that your y is alone. When that y is alone, it is in slope-intercept form. So now, all we need to do is take this point-slope form and we need to solve for y. So to solve for y, we are going to change the minus and negative 3 to plus a positive, and then we will distribute our 2 throughout. This will give us y minus 2 is equal to 2 times x is 2x, 2 times positive 3 is plus 6. Solve for y, we then would have to add 2 to both sides, which would leave us with y equals 2x plus 8. This is now in slope-intercept form and would be the equation for a slope of 2 that passes through the point negative 3, 2. We're going to do another problem with that same process. This time our slope is 2/3 and we pass through the point 2, negative 1. Once again, we cannot jump right to slope-intercept because we do not know the y-intercept. We are simply just given this point. So we're going to put this into point-slope form first. So y minus y1 equals m times x minus x1, where your point here is your x1, y1. So y minus y1 is negative 1 equals m, 2/3 times x minus your x1 is 2. Now, to get this into slope-intercept form, we just need to get the y alone, so we are going to solve for y. So to do that, our minus and negative 1 here would become plus a positive, and then we would want to distribute the 2/3 to both of those. So we'd have y plus 1 is equal to 2/3 x. 2/3 times negative 2 would be minus 4/3. Okay, now continuing to get the y alone, now we would have to subtract 1. So now we have y equals 2/3 x, and then negative 4/3 minus 1 is minus 7/3. So there would be our slope-intercept form. Now if this, you could not jump to minus 7/3 really quickly, I'll show you how. If you subtract 1, that's the same thing as subtracting 3 over 3. Negative 4 minus 3 is negative 7. Keep your denominator of 3, and that's how we got that y-intercept, or the minus 7/3 at the end. Let's do a couple more. This time, notice that we say we want the line that is parallel to this formula, y equals 1/3 x minus 2, and it passes through this point. So we have a point, we need to find the slope. What is it? Notice that this formula that we were given is in the form of y equals mx plus b. While the slope is whatever is attached to the x. So this 1/3 here must be the slope. If we want the line that's parallel to it, a parallel slope to 1/3 is also 1/3. So we're going to use a slope of 1/3 and the 0.24 to plug this into our point slope form. And then we will solve for y to get it into slope intercept. So y minus y1 here is 4 equals m, slope of 1/3, times x minus x1 is 2. Solve for y. So we will distribute the 1/3. Y minus 4 is equal to 1/3 x. 1/3 times minus 2 is a minus 2/3. Now we'll add 4 to get our y alone. So y is equal to 1/3 x. Negative 2/3 plus 4 is 3 1/3. So there is our slope-intercept form, y equals 1/3 x plus 3 1/3. These two equations would be parallel to one another. You can clearly see that because both of their slopes are 1/3. Okay, another example similar. This time we are passing through the point negative 1, negative 2, and we are perpendicular to y equals 1/5 x minus 3. Notice that the y is alone here. So we're once again going to compare it to our slope-intercept form of y equals mx plus b. The slope is always attached to the x. So here, the slope of that line is 1/5. Well, we are perpendicular to it, so the perpendicular slope to 1/5 is negative 5. So we're going to use the slope of negative 5 with our point negative 1, negative 2. And we will then put this into point slope form. So y minus y1 is equal to m times x minus x1. So y minus y1 is negative 2 is equal to m is negative 5 times x minus x1 is negative 1. Minus a negative 2 becomes plus a positive, minus a negative 1 becomes plus a positive. Then we'll distribute our negative 5 throughout. So when we do that, we now have y plus 2 is equal to negative 5x minus 5. Solving for y, we would subtract 2 from both sides. So we have y equals negative 5x minus 7. This would be our line that is perpendicular to y equals 1/5 x minus 3 that passes through that point negative 1, negative 2. Here are just some more examples of these. This time we want to be perpendicular to 2x equals 6, and we pass through the point 4, 8. Well, 2x equals 6. There's no y there, so we can't get y alone. Notice here, though, that x would equal 3. Now you have to recall what happens when we have x alone. When we have x alone, that means that we have a vertical line. Well, what is perpendicular to a vertical line? A horizontal line. Well, how do we write horizontal lines? Horizontal lines are y equals, vertical are x equals. So to write the equation of a perpendicular line to 2x equals 6, we just need to figure out what the y value is that it's going through. Well, look, it's passing through the point 4, 8. Which of those is the y value? The 8 is. So this means we have a horizontal line at y equals 8. Sometimes, graphs like this, it's going to be helpful for you to just draw a diagram. So if you plot x equals 3, we know that that crosses the x-axis at 3, never crosses the y, so it's vertical. Then if you go and plot your point 4, 8, we want to be perpendicular to it, so we could draw our horizontal line through there, and then we could easily see that y should equal 8. Here's another example, set up slightly differently. This time we are parallel to the equation 2x plus 4y minus 6 equals 0, and we pass through this point negative 3, 4. Two options. Option 1, graph the x and y intercept and find slope. Option 2, solve for y and find slope. It does not matter which option you do, it's completely up to you. I will show you how to solve for y. So here we have 2x plus 4y minus 6 equals 0. So we'd want to start off by adding the 6. So now we have 2x plus 4y equals 6. We want y alone, so we'll have to subtract our 2x. So 4y equals negative 2x plus 6. I put the x in front because I know I want to compare it to y equals mx plus b. Then I have to divide by 4, making sure I divide everything by 4. So I get y equals negative 1/2 x plus 3/2. Now looking at this, I can clearly see that this slope is negative 1/2. I want to be parallel to it, so I'm going to use a slope of negative 1/2. Okay, I have to erase some of this so that we have enough space to work. So here, we are now going to use the fact that we have a slope of negative 1/2 and a point of negative 3, 4, and we're going to put this in point slope form. So y minus y1 equals m times x minus x1. So y minus y1 is 4 equals our slope of negative 1/2 times x minus a negative 3. Minus a negative plus a positive. Now we'll solve for y, so we distribute our negative 1/2. So now we have y minus 4 is equal to negative 1/2 x minus 3/2. To get y alone, we now need to add 4. So y equals negative 1/2 x, negative 3/2 plus 4 is 2.5. So y equals negative 1/2 x plus 2.5 would be our line that is parallel to the equation 2x plus 4y minus 6 equals 0, and it passes through the point negative 3, 4. Stay tuned for one more example and variation for how you can see these types of problems. We now are going to pass through 2 points. So we're going to pass through the point 4, 8 and negative 2, 1. We need to find the slope. We have a point, we need the slope. Well, we know how to find the slope between 2 points is y2 minus y1 over x2 minus x1. You can go ahead and label them if you need to. So y2, 1 minus y1 is 8, over x2 is negative 2, minus x1 is 4. 1 minus 8 is negative 9, negative 2 minus 4 is negative 6. This would then simplify to 3/2 by dividing both top and bottom by a negative 3. Now we have the slope. You can then pick whichever point you want to work with. It does not matter. So I'm going to pick to work with the point 4, 8. If you pick the other point, you're going to get the same exact final solution for our slope-intercept form. So we will then be able to put this into point-slope form. Y minus y1 equals m times x minus x1. So y minus y1 is 8 equals our slope of 3/2 times x minus x1 is 4. So we'll have to distribute the 3/2. Y minus 8 is equal to 3/2 x, 3/2 times 4. Well, 4 divided by 2 is 2, times 3 is 6, so minus 6. Then we would need to add our 8 to both sides. So we have y equals 3/2 x plus 2, and that would be our slope in, or our line in slope-intercept form.